Now we're continuing with exam 1, and the second problem here is going to be a projectile problem. Here's the question. On the TV program, That's Incredible, in the fall of 1980, notice this exam is 1984 that I gave many years ago. So That's Incredible. In the fall of 1980, a daredevil attempted to ride a motorcycle up a ramp and jump over 30 vans parked side by side. Now, you don't want to be doing this. This is very, very dangerous. And this is probably Evel Knievel that was doing this. And he hurt himself many, many times in the hospital. Here, in this particular case, he attempted to jump over a ramp of 30 parked cars, and since each van 6 feet wide, the array of vans was about 200 feet, and allowing a little space between each van, so they're giving you that. Take the ramp to be 45 degrees and find the velocity of the motorcycle as it leaves the ramp to clear all the vans using the range formula, and they give you that. Due to air resistance, the actual velocity will be somewhat higher that you would need because of the air resistance. The driver did not complete the jump in 1980, which would have broken the world's record of 190 feet. Instead, his cycle exploded as part of the stunt in midair, and he fell into boxes, nearby coming to a stop in about 0.2 seconds. Estimate the x component of his deceleration by assuming constant deceleration in the x direction and taking an initial horizontal speed of 90 feet per second at the instant before the explosion. How far did the driver travel horizontally during the deceleration period? Okay, so here, part A, the initial speed, V naught, we're given that R is 200 feet, theta is 45 degrees, and we're given the range formula, V naught squared over G sine of 2 theta. So we're solving for the V naught, so the V naught squared will be R times G divided by sine of 2 theta. So this is going to be 200 feet times 32 feet per second squared divided by the sine of 90 degrees. So when we work this out, actually, sine of 90 is 1, and you could do this in your head. 200 times 32, 6,400. Notice that's going to be feet squared over second squared, the units. You take the square root, hey, that square root of that's going to be 80. So that's 80 feet per second. And 3 feet a yard is roughly in meters, so if you divide by 3, you're going to get the meters. So it's not quite like 30 meters per second. So here for part B, deceleration in 0.2 seconds. And here it's saying the initial speed here is, actually in this particular case, if you want to read this problem carefully here, this one is saying, so I don't like this problem because I don't like the 96. If you're starting out with 80, let's fix this. Let's just say, this to say that wasn't given. Let's just take that out. If we take that out, then we could find the velocity, initial velocity in the x direction as v naught times the cosine of 45. Now, see, that's better to do that. So that's then 80 feet per second times square root of 2 over 2, 40 times the square root of 2 feet per second. Now my calculator is my phone and it's being used to make this recording, so this is 1.4 and take the square root of 2. So 4 times that is going to look like the initial speed is 50, 52, let's see, 56. 4 times 4 is 16, and that's 56 feet per second. So if we have 56 feet per second, and we want to find out what the acceleration is, we can use this formula, v naught x plus the acceleration, I guess being the x direction, times t. And that acceleration here, so your velocity, you can come to rest, so that's going to be 0. Just put the x down to emphasize we're doing x. And then this here is going to be your 56 feet per second. And this is going to be 0.2 seconds. So you're going to have here ax times 0.2 seconds is minus 56 feet per second. Then you're going to have ax is minus 56. This is going to be divided by 0.2. And that's going to get you feet squared. No, that's going to get you feet per second squared. So this is minus 56 over here 1/5. So this is going to be a negative 5 times 56 feet per second squared. And it went in terms of g. Well, if we do that, 1g is 32 feet per second squared. So now you'll get how many g's. Now, don't have a calculator with me since it's my phone, so if I were to just say here, we're looking at minus 5 times 50 over, say, 30, like this. This would be minus 250 over 30, and that would be minus, the zeros would cancel, minus here roughly like minus 8 or 9g. Now you want to be very careful. This is very dangerous to have g-force like this. This is high, but for a split second, someone like a professional stunt person, can handle something like this. But I would be very, very careful with g-forces, collisions. People can get injured very, very easily. For part C, the distance, we'll use the kinematic formula that the distance is 1/2 the initial plus the final velocity times the time for the acceleration period. Notice that here we're really taking the average velocity. So the average velocity would be 56 feet per second, plus 0 divided by 2. And the time is 1/5 of a second. And the 1/2 of the 1/5 gives us a 1/10. So that comes out nice, 56/10, which is 5.6 feet, which is also equal to 1.7 meters.